Having covered some of the basic patterns of the global water cycle, we're now going to turn our attention to anthropogenic changes in the water cycle. Human-induced climate warming has accelerated the global hydrologic cycle through increases in both evapotranspiration and precipitation. Essentially, just because it's become warmer, that's going to cause a lot more evapotranspiration and, as a result, more precipitation. One of the main patterns has been increases in precipitation north of 30 degrees north latitude. So if we look at these northern hemisphere higher latitude systems, there really has been an increase in precipitation that's occurred over the past 50 years or so. Now, in addition to that, there's been an increase in the days of large storms, essentially. So this is a trend, percent per decade, over the past roughly 50 years. And these are annual precipitation trends. So we're taking a look at what percentage of the rainfall came from large storms. Anything on the blue to purple side is a positive increase. And what we're seeing for a large portion of the world, that we're having a larger proportion of the rainfall come as larger events. So we're seeing a greater proportion of bigger storms. These data come from the 2007 IPCC report. IPCC is the International Panel on Climate Change. It's one of the most important research documents that we have that summarizes a lot of the global trends as well as regional trends associated with climate. And so here we can see, because it's been getting warmer, we're going to have a lot more evaporation, and we're going to have a lot more large storm events. This is another pattern that shows it on a decadal scale and what that pattern actually is. These are the observed trends, again, percent per decade over the past 50 years, and it's a contribution of these wet days over time. What we have here is kind of a standardized graph, and we're going to take a look at how this has changed over time. And what we can see is that there wasn't really much change in how important those big storms were until roughly the mid-80s. And then, especially in the 90s and the early 2000s, we're seeing a lot greater fraction of precipitation come down as large storms. For the most part, that's due to changes in climate, the warming of the world, a lot more precipitation coming in large storms as a result of greater evaporation. So that's straight up changes in temperature causing changes in the pattern of precipitation. In addition, we have land use change is a way that humans have affected global water cycling. Now, when humans change land use, when we change the type of vegetation that's there and the composition of that vegetation, we're changing the quantity of energy that's absorbed. So we're changing albedo. We talked about that. But also the pathway of energy loss. How much of that energy is being lost as sensible heat versus latent heat flux? How much evaporation is occurring out of that system? And we're also affecting the moisture content and the temperature of the atmosphere. So some of the main driving gradients for changes in evapotranspiration are also being altered at the same time. Now, some of these land use changes are things like going from forests to grasslands, places with relatively high leaf area index that have a lot of evapotranspiration, to grasslands, which often have a lower leaf area index and are going to have a lot lower evapotranspiration. But in addition, other areas are undergoing a shift from grasslands to forests. And some of this are from the plantations that we talked about earlier that are going into former grasslands. And that's also going to change water cycling on a regional basis, because we're really shifting to a higher productivity, a higher leaf area index, higher evapotranspiration system. In addition to changes in land use by changing the vegetation type, we also have a lot of irrigation. And essentially that's going to bring water to the surface, and that's going to get it into the biosphere, into the more active part of the biosphere. So irrigation pumps a lot of water into the atmosphere. Now, the consequences of changes in the water cycle. Society depends most directly on some of the smallest and most vulnerable pools in the global hydrologic cycle. We talked about how small that pool of soil water is, how short its mean residence time is, and how vulnerable it is to changes in atmospheric circulation, for example. And society depends on this pool, the soil moisture pool, really more than any other pool. Now we've gotten away from some of that by increasing irrigation. And irrigated cropland has increased 5 times during the 20th century. So we've really increased the amount of water that's being put on the land and tried to reduce our dependence on soil moisture that doesn't come from irrigation. Somewhere on the order of 40% of the global crop production is associated with irrigated lands. In total, associated with irrigation and other factors, people now use somewhere on the order of 25% of continental runoff. This is figure 14.4, and this shows in the first panel on a global basis what the world population is, and then how much area is under irrigation. And you can see that these two trends more or less are congruent, so they parallel one another. The time scale here starts at 1900, so we're looking at roughly the past 100 years or so. Now, the second one shows the total withdrawals and the per capita withdrawals. The total withdrawals have been, if you take a look at all the water used by humans, has really mirrored that world population size. And per capita withdrawals has really been relatively stable. So each individual, on average, is not associated with a greater withdrawal since 1940. That's been relatively constant, but it's really been the increase in the world population that's driven changes in the total withdrawals. Now, if we take a look at water withdrawals, and this is cubic kilometers per year, and this is just for the US. The others were on a global basis, but we have better numbers on the US. Here's a pattern of total withdrawals. They've leveled off some since roughly 1980, but they were definitely increasing for 50, 60 years before that. Of the greater uses, hydroelectric power is relatively high. And there's a lot of dams that were built during this era, and a lot of water was being stored and utilized for hydroelectric power. But in addition, if we take a look at irrigation, that's gone up pretty steadily. The magnitude is slightly less than hydroelectric, but a lot of water in an increasing proportion is really being used for irrigation. So as we withdrawn more water from runoff and taken it out of what its cycle was before, we've used a lot of that for hydroelectric power and a lot of that for irrigation. On the whole, industrial uses and public supplies have been relatively low. It's not a large fraction compared to irrigation or hydroelectric power. So some of the patterns for anthropogenic inputs that we see, we're seeing a lot greater increase in irrigated area and a lot more water being used for irrigation. This is on a global basis. But per capita, although those total withdrawals are relatively high, per capita is relatively low. Each individual is not associated with a greater withdrawal of water. And in the US, a lot of that water has really gone to hydroelectric power or irrigation. And those other factors are relatively small and don't constitute a large impact on the global water budget.